5.3 is it's all about trying to find relative extrema and intervals of increasing and decreasing on an open interval. Bless you. It's not terribly different than what we did on a closed interval, but there's just a lot more involved, and for whatever reason, it takes students a while to get adjusted to the method. Like it 100% makes sense once you see it, but it's just, it doesn't always click right away. So let's start with, where'd that fall from? Up there, I guess. Let's start with relative extrema. So absolute extrema is pretty easy for your mind to comprehend just because the very top, very bottom. Relative extrema is just saying you're looking for the top of a little local area. So for most people, they think of it as the top of a hill. Relative min is the bottom of a local area, which would be the bottom of like a valley of some sort. Every graph can have multiple relative maxes and relative mins. It also doesn't have to have any. It's kind of the same as absolute, where it's just whatever's there is there. So if I circle these, that's the top of a hill. That's going to make it a relative max. C is the bottom of a valley. And obviously this is very technical terms here. Relative min. This is still considered the top of a hill in my mind, even though it's a sharp point. We'll call it the top of a mountain if you really want. And then F does not count because it's an endpoint. So relative maxes and mins can only be in the middle. Actually, this isn't even an open interval, so I'm not sure why it's whatever. How should I phrase this? I don't want anybody to die in here. You okay? You can get a drink if you need one. Oh. I've got a string going of 21 years with no deaths in the classroom. Let's not change that, Stephen.
How long have you been teaching?
21 years. What? Why would you ask that?
Because I want to make sure that's 21.
Oh, okay, that's true. That's fair. That's a fair question. Yeah, I was saying it in jest, but I have definitely never had that happen. I already forgot my number. 34 is Michaela. I bet you're excited. Using calc terms. So, like functions, derivatives, all that kind of stuff. How do you describe the top of a hill? Hey, you can look at the picture if it helps.
Where the slope is zero.
Except for that point one's not. I mean, it's a good thought, though. So instead of,
Changing direction.
oh, okay, good. But changing directions isn't calcy.
Where the slope is going from positive to negative.
Oh, good. Excellent. Excellent job. I wasn't even sure if that question was going to get that answer, but that was very good. So the way we're actually going to look for relative maxes, I don't care where you want to write this down. A relative max is specifically when your function changes from increasing to decreasing. Now, increasing and decreasing, honestly, isn't really the best verbiage either. I think you understand that the best. What do we usually say instead of increasing when we have equations? So the slope is going from positive to negative. So f prime is going from positive to negative. Now, it is super annoying that we're not going to be allowed to write positive and negative in our answers. On the AP test, they prefer you to say f prime of x is greater than 0. Bless you. What is going on in the room today? So f prime of x is greater than 0 is a specific way of saying the slope is positive, right? Like f prime of x represents the derivative slope. And then f prime of x is less than 0. Okay, next person who probably has a much easier answer since Michaela led you to it. 32. Lucas. I actually started writing him down because it always seemed to take forever for people to volunteer info. Okay, Lucas, how do we say a relative min? Perfect. Decreasing to increasing. Now, we always read everything left to right, and so that's why we're allowed to kind of write it this way. So we would say f prime of x is less than 0. That's a bad less then. To f prime of x greater than 0. Now, are we okay with that? Do you guys have questions on that? Okay. Because what we're obviously trying to get to is we're not going to have a picture of any sort. We're just going to have an equation, and we're going to have to try to figure out where our graph is changing from increasing to decreasing to relative maxes, relative mins. Okay, so I presented a different way than this packet does, and I'm going to skip straight to example 3, which I think is right there. And I want to kind of show you how we're going to do these. Now, the directions on example 3 say find where it's increasing and decreasing. We're going to add on to that, and we're also going to find relative extrema. A or E? Rel eta, rel eta? Should be written on the page somewhere. A? I don't know why that seemed wrong. Spelled the same as family relative, correct? I should know. We'll pretend I do. Okay, so we've got our original function. Obviously it's written down already. I'm just gonna. So it's a cubic, so we're expecting it to, oh shoot. We're kind of expecting it to behave like an odd function where it goes down on one side, up on the other. So in my mind, I'm kind of picturing possibly what it looks like. I don't know any details about the curves, but I know it is down on the left-hand side, up on the right-hand side. Oh, Fiona was it. That's right. Okay, so Fiona, be prepared for backup. Okay. $38. What's with all the big numbers? Cody. Yeah, I know the desks are all over the place. Like the numbers don't really seem to go correct. Okay. Relative extrema happen at critical values.
Of 0 when it's undefined or equal to 0.
When what is? But you're correct.
The derivative.
Perfect. When the derivative is undefined or 0. So that means I need to find my derivative And the fact that this is a polynomial tells me that there's not going to be any undefined values. I'm going to need to look for zeros if there are any. So 2x squared minus 2x minus 4. So 2 times x squared minus x minus 2 equal to 0. Do I need to call on people for this? Are you pretty good at this part by now? Should I be worried about your factoring? Okay, so 2 times x minus 2 plus 1. And that gives me critical values at 2 and negative 1. So these are critical numbers right here. It's possible there'll be critical points later, like if we write them as a point. And this 2 out front gave me nothing. Now, this particular function is negative infinity to infinity, which is an open interval. So I obviously can't be testing any endpoints. I also know that there's not going to be any absolute max or min because it's a cubic, which means if it's down on the left, up on the right, that goes all the way to infinity on both sides. So that's why we're kind of looking for relative extrema, where something happens in the middle possibly. We're going to write a number line. Now I do this a little bit different than the packet because the packet uses a table, and the table absolutely just messes me up. If you're a person that likes tables, fine, make a table. I like to make a number line because for me it just kind of helps me visualize things. On the AP test, neither the table nor the number line I'm making are actually allowed as graded work. You're allowed to write them and to help you figure things out, but for whatever reason they're not official. You'll know more about that as we go more into this. Okay, so my number line goes from negative infinity to infinity. I'm going to put any critical numbers I just found on here. And, well, it really doesn't matter since it's not too difficult here. So I'm just going to put them on there. Now, on this number line, I'm going to write where my graph is increasing or decreasing. Let me call them. You know, I should be smart and just roll a whole bunch of numbers at once, so I just have them all ready to go. Perfect. 22. Brendan, what's the slope at negative 1 and 2? I don't, but I mean, if you want, you could. Well, I was kind of asking you. Okay, so why don't we need to plug it in? But you're correct. Yeah, we actually kind of already just did that, right? So our critical values are when the slope is 0 or undefined. So I'm going to put this up here just as a reminder to myself. If it was undefined, I would put like does not exist or something instead. So this little circle actually represents 0. If you want to write the word 0, go for it. I don't, I'm lazy, so I'd like to shortcut stuff. How are we going to figure out what the slope is in my sections? Because I see that my graph has 3 pieces. This first piece, oh shoot, I wrote the 0 in the wrong spot. Not that it matters that much, just. My first interval is from negative infinity to negative 1. My next section is from negative 1 to 2. My third section is from 2 to infinity. If you were to write this info as a table, this is the headings on the table, is these intervals. So it's kind of like the same way to present it. A table for me just for some reason confuses my brain. $14. Ellen, how do we figure out if it's increasing or decreasing? Good. We're just actually going to take a number that's in that section, plug it into the derivative. So these are going to be called test values. So we are going to test, you generally just pick an easy number in that section. So from negative infinity to -1, what's going to be an easy number to check? -2 would be fine. -10 would be fine. 0 would not. Yep. Well, that's why I was getting to it. It's really easy for us to pick 0 because we do all the time. But 0 is only going to be in one section. So I actually usually pick like a bigger number like 10 myself. Go for -2 if you want to. I'm going to test -10. So f prime of -10, is it positive or negative? That's all we care about. We don't actually care about the number. Thanks. So we're just trying to figure out if it's positive or negative. I'm not even going to plug it in the original derivative. I'm going to plug it in the factored derivative. That's why I kind of like picking the bigger numbers. 2 times -12. So 2 times -12 times -9 would give me a positive answer. So all I care about is that this section has a positive slope. I don't care about the number. The entire section is going to have positive slopes. So underneath this, I'm going to write increasing. And I don't have enough room. But I know that whole entire section is increasing because I have a positive slope. Yeah, but yes. So that's the easy answer to this one is you kind of know what a cubic looks like already. Most of the functions we're going to get, you probably have zero idea what they look like. So this is how we go through the process. I'm kind of purposely trying to pick an easier equation that we're comfortable with, even though this is a weird equation. We're a lot more comfortable with polynomials than other things. But yes, you are correct. Okay, number 4, Stephen, and number 27, where's 27? I should have called on you before you left. Are you coming back? Okay. Where's 27? Oh, yeah, the empty desk. 25. Ava. Okay, Stephen and Ava, here's what I would like you to do. I would like you to, Stephen, why don't you pick a number from -1 to 2, put it in the derivative, and figure out what kind of a slope we get. Ava, same thing, but third section. Almost guaranteed you're going to test 0. Ava, what number are you plugging in? Okay, that works. FYI, part of the reason that I just wrote these numbers out and didn't care about the answer is because this is traditionally a setup for when you don't have a calculator. Because if we had a calculator, we could just graph it and look where it's going up and down. So that's part of the reason that we don't care about the number answer. I see a ton of people calculating. You're not going to have one. So that's why we approach it without one. I mean, you can if you want. I'm just telling you on the test you don't. Stephen, what did you get? You don't sound super sure there. What should we plug 0 into? Okay, So 0 minus 0 minus 4, that one would be negative 4, so that definitely is a negative answer. Ava? Perfect, that's what it should have been. So we've got increasing, decreasing, increasing. Now, one thing I want to warn you about, it does not always alternate. Don't get in the habit of just writing them alternating, because they don't always alternate. This one we kind of already knew the answer. And frequently they do alternate, but you definitely are going to get plenty that don't. So try not to get in the habit of just like alternating. Okay, so relative extrema can only happen at the critical values. We had 2 critical values, and they don't have to be a max or a min, but they can be. 3. Jacob. At x equals -1. Is that going to be a relative max, relative min, or nothing? And how do we know?
It's gonna be a relative max, and it's gonna be, the slope is gonna be.
Perfect. Perfect answer. If you find it helpful, you could certainly draw a rough sketch of this graph too, you know. Like increasing is going up, decreasing down, up. So like when I'm looking at this, I can tell that that's the top, that's the bottom. If you find that helpful, you can do that. But like I said, on the actual AP test, this thing isn't considered official work. It's weird. I don't know why they don't. Do you want to answer the next one? Do you want somebody else to go?
I'll answer it.
Sounds like you had a good handle on it.
It's a relative min because the slope's gonna be.
Perfect. It's a relative min because it's decreasing to increasing. So if it asks you to justify why it's a relative max or min, you would say it's a relative max because f prime of negative infinity to -1 is greater than 0. F prime of -1 to 2 is less than 0. Okay, and then the last answer that we have to give out of this, 35. It's all over, yeah, what the heck, this is all over the place. Wait, who said me? You're 35? I have 33 written down. I have 33 written twice. That's awesome. I did a great job of. Let's fix this. Okay, so Tununj, do you know the last thing we're answering? So in the actual original question, it said, where is this graph list the intervals of increasing and decreasing?
So it's increasing from negative infinity to -1, decreasing from -1 to 2, then increasing from 2 to infinity.
I would say close to perfect. So what we're going to do is we're going to say it is increasing, f of x is increasing from negative infinity to -1 and from 2 to infinity, and f of x is decreasing from -1 to 2. But excellent job. This is going to be called the first derivative test. I don't think it was actually on the title of the section of the page, was it? Yeah. So this is going to be called the first derivative test. Basically, this entire thing that we just did, you're not always going to have to do all of it, but frequently you do. I don't know. It seemed like you guys caught on to that pretty decent, though, huh? Let's find another polynomial. Otherwise, I can make one up. Here, that's a good one. Example 4. And above example 4, you'll see that this is kind of the way that the person that made the notes likes to write out the first derivative test. I'm not a huge fan of it just because it's a lot of symbols. I don't know. Table information screws me up, like I said. But if you like the way it's laid out in the packet, and that seems logical to you, you are welcome to use that too. Like, I'll understand it on the test. The whole point of the first derivative chart that we lay out It's just a way to organize information together. That's all it is. Okay, so if you guys can, do you need some guidance on this next one, do you think? Or do you think you can set it up on your own? Okay. Find critical values. Make a number line with the critical values. That's the start. And you can kind of already see why this section takes us a while to go over. Like we're basically going to be doing 2 problems today. So it just takes a bunch of days for examples. Are the winter court people wearing like sashes and stuff today? Because I couldn't really hear the names at all first hour. Is anybody in here in the winter court? Okay. So this one's tough to kind of picture mentally for you because fourth powered equations can either look like a parabola or it can look like a W. It's one of the two. The only thing you really know is that it goes up on both endpoints. 10. Kale, when you get a chance, I was hoping you could go up there and write down f of x, f prime of x, and or with f prime, write any kind of critical numbers that go with it. 29. Chendon, when you get a chance, I was hoping you could go up there and set up the number line with the critical values and the intervals. Now, for your benefit, the equations are traditionally picked pretty specifically so that your derivatives can be solved by hand. If you need a calculator to solve the critical values, then it's kind of pointless. So these all traditionally will be set up to be solvable.
Should I show the work and just put the critical value?
You mean like the factoring part?
Yeah.
Yeah, you better show that because that's what we'll end up plugging a lot of info into, I guess. Or anybody watching the video can see where it came from. Okay, so as Kale's doing this, if this looked like a parabola, we basically should only have one critical value because the bottom of the parabola would be the only critical value. Since this one has 3 of them, that tells me it's most likely going to look like a W. Now, I don't even know what it says in the directions, but I wanted us to try, oh, that's perfect. The directions are exactly what I wanted to do. I was going to say we should try to figure out the intervals and critical extrema, or relative extrema. Perfect. I'll make it a little bit smaller so everybody else has room, but that's perfect. Uh-oh. How do I make this smaller? Hold on. Oh, I forgot one. There, now you got more room on the right-hand side. You You probably want to make it slightly bigger because you're going to have a lot of info on there. On paper, it's easy to write small, but up there it's hard to write small. Yeah, that works. It's very aggressive arrowheads. I like it. Comma. All of these intervals are going to be open endpoints or open intervals as well, because the interval would never include that critical value. Perfect. Nice job. Okay, so we've got one, two, oh, I need another one. We need 4 people up here. Whoa. It's dropping out the bottom now. This roller is way worse than the old one. 33. Eli was not here. Good thing I have an extra one rolled. 11. Jesse, do you think you can write down the info from negative infinity to negative 2? So the info would include the test value and then whether that section is increasing or decreasing. 30, empty. 23. Oh, Junwoo. Second section, I think we're on, from -2 to 0. So whenever you have that info done, write the test number, whether it's increasing, decreasing. If you're done already, you can just put it up there, yeah. 37, UK, third section. Yeah, yep, 0 to 2. 19 is going to be Zach. You probably only have half an idea what's going on.
No, I think I got it.
You got it? Do you think you can fill out the fourth one?
Yeah, I think so.
Okay, perfect. Two people can write at once whenever you guys are ready.
Wait, do you want me to write just like increasing or decreasing?
Oh, no, the test number, whether it's positive, negative. What? If you just write increasing on the test, it 100% will not get you any credit.
But that means it's positive.
I'm not arguing with that fact.
Right?
I'm arguing with the fact that how did you get that? Oh,
So on the test, we just have to write out like what our test value was, and then say positive, negative.
yeah, I'm not even looking for an answer because you're not going to be using calculator. So you can just say if the answer was positive or negative. I basically just check if you're using correct test numbers. Like they're kind of intended to be done in your head, so it's not something you have to write out. Now I realize it's a little more difficult writing on the smartboard, but I'm hoping it's going to be more organized than this on paper. I know it's hard to write small up there, so. It looks like it says decreasing first section. Second section, you wrote that your test number had a negative answer, but then you wrote increasing.
That's positive. That's positive.
Well, it's definitely written as a negative. Third section, negative slope, decreasing. Fourth, positive, increasing. Okay, excellent. Let me draw on here. So decreasing, increasing, decreasing, increasing. I'm kind of a visual person at times, so that helps me like absolutely mentally picture whether it's a max or min, but you don't need to. 24, Sahasra. No. What did you want to go short by? Sahi? Why do I not have that written down? I bet you I did on my old seating chart. I'm happy I remembered that I was supposed to go by nickname. So, okay, so Sahi. Any kind of critical, any kind of relative maxes or mins. So what do we have? I think you said, can you, I couldn't hear.
It's going from decreasing, right, to increasing,
Oh, yeah.
so it's a relative.
So at x equals -2 is a relative min.
Okay, and then at x equals 0, it's from increasing to decreasing, so it's a relative max.
Perfect.
And then at 2, it's from decreasing to increasing, so it's a relative min.
Perfect. Nice job. And the last person, because we won't be starting a new one today. Do I actually have number 1? I do. And James, are you? No, you're not number 1, are you? Number 1 is empty? Oh. James, you're 2, correct?
Yeah.
Okay. 17, Atharva. Intervals of increasing or decreasing.
Increasing at negative infinity to -2.
You're saying it backwards.
Oh, yeah. But
So it's,
decreasing. I was thinking about the max and mins.
oh, got you. Okay, so you're starting with decreasing.
Yeah, decreasing at negative infinity to -2, increasing at -2.
Pause. You're not wrong. I know what you're saying is correct. When you list the answers, list all increasing and then all decreasing.
Okay, decreasing at negative infinity to -2 and at 2 0 to
Perfect.
increasing at -2 to 0 and at 2 to infinity.
Yeah, perfect. So it's decreasing from negative infinity to -2 and from 0 to 2. And it is increasing from -2 to 0 and 2 to infinity. Okay, good. This pretty much encompasses a lot of it. Like, now, polynomials are definitely what we start with because most of you can kind of picture those in your mind and they're not weird, right? Like weird things don't happen in the polynomials. So we've got about 15 minutes left where you guys are welcome to start working on polynomials in the homework. I would hold off on any other type of equation. So tomorrow we'll probably be doing rationals. So we'd have asymptotes that kind of throw things off. And then Wednesday will most likely be like ones that have roots because the roots kind of throw off critical values. So that was a lot of info. Okay, go ahead.